So our preparations for the exam, we'll start with looking at sets. Now, we don't go to notes and start reading the notes for sets and doing everything. The key thing here is that we already have an understanding of what a set is. So what you are doing today is answering questions that we expect in the exam. Should we not see what we are doing today, at least to see similar things? So we'll be able to apply our knowledge today to be able to answer that question which is there in the exam on sets. So there's no need of you skipping that question because we are here to prepare for exam. When we say sets, we mean sets as you understand them, having set A, set B, get intersection union. We mean SADs, add 2 plus 3 root 4, 2 plus 7 root 3. We also mean binary, the binary operations, all these 4 undersets. Undersets, we also have complex numbers. So this is what makes up sets. And so you only expect 4 questions from here, or the other one, if we are to separate it, we can say rational and irrational numbers, though these the 4 undersides and the irrational numbers. Okay, so I've just given them another question. So now what we are doing is we are going to the past papers. With me here, I have some past papers. So in these past papers, for today's task, we are going to these past papers and answer only questions based on this coverage: sets, SADs, binary, complex, rational, and irrational numbers. And what will remain in the past papers that you're going to see yourselves anywhere where you see them from, it will be now your duty as a responsible student to practice your knowledge on those questions. Those questions involve even your tutorial questions. You go to the tutorial sheet and answer questions on sets. So question 1. So I don't think there'll be even need to state which past paper is coming from, as long as I state it. Or if you so wish, question 1 from 2020. A1. Simplify the set B minus A union A complement. So about simplifying sets, there will always be union, intersection, complement, minus. So for minus, by definition, if I have A minus B, this is exactly the same as A intersection B complement. Okay, so if there's this combination of minus, union, complement, intersection, you first change the minus to intersection so that you can reduce the operations that are there. So this is going to be, we go to minus and change it. So we have B intersection A complement union A complement. Then now we got the complement outside, and De Morgan's law say if I have A intersection B and there's a complement outside, when the complement goes inside, it will change the operation from intersection to union. Okay, this is De Morgan for intersection. De Morgan for union, A union B complement is the same as A complement intersection B complement. This is telling us that the complement changes the operation from intersection to union, from union to intersection. So in this case, we are going to have B intersection A complement intersection. If I find double complement, I just mean the set inside. So for you to write A complement, this is the same as just saying A. Because you've gone outside A, now you're asked to find the outside of A, so it will be A itself. And then now we take that guy inside. So we're going to have B complement union A intersection A. This will always be equal to A. The key thing here is if I have this set outside and I have the set inside and the operations union is different from this operation intersection, then it means that you just have the set A. That is both outside and inside the brackets. So your answer is A. So this must not be an issue. So you keep that in mind.
So, sir, if the
someone else can pick it up. If
okay, sir, if the operation they're the same, like they're the same. So meaning our final answer, maybe if they were the same, we're going to have
if you have big complement
open bracket
union A, then this A is not doing anything because it's here already. So we just have big complement union A.
Okay, thank you.
Sir, my question is, so what if it was B intersection A, close bracket, union A? Was it also going to be A?
Yes, because we talked about the set being outside,
at least you have my number
and outside, and also opposite operations. Okay, then we got the second part. Given the sets A is equal to -2,6, B is equal to -5,3, C is equal to -1,8. Given that these are subsets of real numbers, find the set A union B complement union C with the complement outside. First thing, I just remind you that when you have an interval and you have these, they will mean that if this is A and this is B, if you draw them on a number line, please include the boundary numbers, include A and B. If one side is open and the other side is closed, include the one which is closed and exclude the one which is open. So now you know that if they are all open, then you open both sides. So to find this one, you can go by simplifying first. Say this is the same as A union B intersection C complement. As you push the complement inside, the union change to intersection, and the complement becomes just B, and then complement remains on C. So from there, you are now looking for C complement. You have A is given, you have B is given. What is not given is C complement, but fortunately enough, C is given. So the universal here is R, and C runs from -1 to 8, meaning that anything outside that, if this is my number line, okay, going this side, you have from -1 to 8. This is where you find C, including this guy, including that guy. So this is C here, okay? C complement means what is not in C. So in C, you won't find 8. I mean, in outside C, you won't find 8 because 8 is in C. So going this side, meaning to infinity. Again, outside C, you cannot find -1. Going this side. Okay, so this is C complement. This is C complement. So now you come here and say, okay, I just want to work with B intersection C complement for now. So my C complement has come out to be -infinity up to -1. Because -1 is in C, it won't be in the complement. Infinite is just a symbol, so it can never be included. Union, because you're skipping an interval here, so you use union. Again, 8 can't be found outside C because it is in C, all the way up to infinity. So this is C complement. You now intersect it with B. So what is B intersection C complement? B is here, -5 to 3. Okay, intersection, we pick -infinity to -1, union 8 to +infinity. So here the simplest thing to do, between -5 and -infinity, go for the bigger number. Which number is bigger than the other? I'll send you bundle. So -5 to -infinity, you pick -5 because it's bigger than -infinity, comma, between 3 and -1, which one is smaller? So -1 is smaller than 3. Okay. Union, you got the next set. Between -5 and 8, which one is bigger? You find that 8 is bigger than -5. Between infinity and 3, which one is smaller? So 3 is smaller. If you find numbers starting with 8, ending with 3, starting with a bigger number, ending with 3, the interval does not reverse its direction. These are not vectors. So this means that this guy here is empty. That's how you know that it's empty. You can even tell from -5 to 3 and 8 to infinity, these two cannot intersect. So you have your solution as -5 to -1. By the way, up to here, it was 3 marks. Here where we are now, 4 marks. So so far, somebody can have 7 marks out of 20. So you know that the battle is on. So far, I've managed to pick the giant and I have 7 out of 20.
Sir.
Yes.
So is it the math that I'm supposed to show this working, or it's okay if I use the number line?
It's okay if you use them. If for now you're able to use the number line and choose the solution, it's okay. For as long as you show the number line. For empty set, we're just saying that since these intervals do not move in reverse, if I have a number line, I can't have 8 and then I come to 3. These guys always go in this direction. When we have this arrow here, we're just indicating that this side until infinity. Otherwise, the arrow is supposed to be pointing But you're starting from negative infinity going this direction. So we never have our arrows reversed. We don't reverse the interval. Or if that is too crucial for you, you can form a number line. Put -5, put 3. It's here. Put 8 up to infinity. Is there any common number here? No common number. So you know this is empty. That's how the empty comes in. Okay, we now go to surds. Express 1 plus √2 squared in the form a plus b √2. Express 1 plus √2 squared in the form a plus b √2. Solution. There's no rationalization here. Your job is just to expand. Since there's a square means multiply that thing by itself. So 1 times 1 is 1, plus 1 times √2, √2 times 1, √2. √2 times √2, the root will disappear, we'll just get the number inside. 1 plus 2 is 3. √2 plus √2, we have 2 of them, √2. This is in that form. So we are done. And this was just 3 marks.
How many marks was this one?
3 marks.
Sorry, the previous one, what was the sir, sorry, for the previous one, what was our final answer?
It was -5 to -1. Did you go back to A?
No, we didn't go
We
back
didn't
to
go
A,
back
sir.
to.
We
We
didn't
didn't go
finish.
back to A. Yeah, there was an interruption, I think.
Yeah.
Okay, let's go to A. So now this is B intersection C, is it? So A intersection mean A union our answer, B intersection C complement is going to be A is -2 to 6 union -5 to -1. So you start from -5. So how am I picking here? Between -2 and -5, I pick the smallest, -5. Between 6 and -1, I pick the biggest, 6. So this becomes our solution. In the case of union. Yeah.
Oh, okay.
And then doesn't it have to be a closed interval for the 6?
For the 6, eh? No, it's open in A.
Oh, all right. I thought it was a closed interval.
Yeah?
Yes, excuse me. So my number line came out as it wasn't like the first one. It was inclusive of -1 to negative infinity, and then for A, it was inclusive of -2 to 6, and 6 wasn't included. And then again, it started from 8, not including 8 to positive infinity. Is that how it came out?
Which number line was that? For the B intersection C complement or for the final solution?
No, for the final solution.
The final solution is just here. -5 to 6. So you check. And then 2, express root 2 over 1 plus root 2 squared in the form P plus Q root 2. Now this question comes after you're given an expression in A to expand. So, I mean in part 1. So your first task here is to remember that this thing is what you are doing. So just place it 3 plus 2 root 2. No need of wasting time. Should you want to expand? That's your issue. You can expand. As long as you get it, you can use it. Then now you rationalize the denominator. So you multiply by the same denominator. Where there is plus, you put minus for the thing with the root. You do the same in the numerator. So now you have root 2 times 3. We have 3 root 2 minus root 2 times root 2 is going to be 2. So we'll have 2 multiplied by 2 because this 2 is fixed, waiting for the multiplication between this guy and that guy because they are similar. Over 3 times 3, we get 9 minus 2 times 2, we get 4. Root 2 times root 2, we get 2. So that now we have 2 times 2, that is 4. So you have negative 4 plus 3 root 2 over 9 minus 8. This is negative 4 plus 3 root 2 over 1. So this is our solution. And why dividing by 1? Okay, see, express 2.534 bar in the form P over Q. The first thing you do here is you let n number, say x, be 2.534 bar. Go to the numbers that are after the decimal point, but not under the bar. Count them. In this case, we only have 1. That one, when you find it's only 1, you use 10. Multiply this whole expression by 10. Multiply it by 10. Because you know that that 0 will move a decimal 1 point to the right. So x times 10, you get 10x is equal to now become 25.34 bar, leaving us with all the numbers after the point are now under the bar. You can even name this equation to avoid confusion. You name it equation 1. Then now count how many numbers are under the bar. There are 2. So you multiply by 100. So you multiply this expression now by 100. It will become 1000 x is equal to 2534.34 bar. You call this equation 2. And then you subtract equation 2 minus equation 1. Okay, so 1000 minus 10, you get 990x is equal to 2534.34 minus 25. So we have these you don't even get why, because they'll cancel each other. These they'll cancel each other. Then 4 minus 5, there you get 14, because now it's going to be 2534 minus 25. Then this is 2, 1, 14 minus 5, that is 9. and then this is 0, then 5, 2. So we have 2509. Then divide by 990, divide by 990. So you get x is equal to 2509 over 990. Where possible, you can do the simplification if you have any number that is closer to simplifying those. Bring it down because they're saying in its lowest term. So by the
So,
way,
sir,
this was
if
4
you
marks.
don't simplify, if you don't simplify it in its lowest term, do you lose it?
If the simplification was too easy, you lose a mark. That's the mark. Out of 3 there, you lose it. Though it's very important.
Can I have the question? So if we didn't have the 5 there on this after the decimal point, if we didn't have a 5, we wouldn't have multiplied by 10, right? Would have just multiplied by 100.
By 100.
And then subtract the original one, right?
Yes.
Right, so thank you.
Okay.
Then my question is on the multiplication on the second equation. Why was it 1,000 and 100?
What is 10 times 100? It's 1,000, so it can't be 100. Because you're multiplying that 100 by equation 1, and equation 1 has a 10. So this was 1, and then you had a bonus question. 2, 5 root 6 minus 2 root 24 plus root 294. Write this under one expression. So you just look at the smallest number in the root. You notice that 6 is the smallest here. Okay, so you got 24 and divide 24 by 6. You get 4. Then you come here and say, I now have 5 root 6 minus 2 root 4 by 6 plus 294. 294 divided by 6. So 6 into 24, it's 4. Remainder, 6 into 29, it's 4. That is in 24. Remainder, 5. 6 into 54. How many times?
The answer is 49.
9 times. So we have 49. Then you come back here and say, okay, so this is 49 by 6. Then you come back and say, this is 5 root 6 minus the square root of 4 is 2. So 2 times this 2 will get 4 root 6 plus the square root of 49 is 7. So 7 root 6. So we have 5 minus 4, that is 1. 1 plus 7, that is 8. So you get 8 root 6. This applies to those questions where they say, leave your answer in the expression like this one with a root 2. This 2 is not that you use to break a number in the root, which is not 2. Okay. Then there was also 2 2A.
Sorry, sir. Sir,
Hello?
yes. What is the purpose of dividing by 6?
Is it okay to repeat the previous page?
This. What was the purpose of dividing by?
The other one, sir, the other one.
By 6, sir.
Thank you, sir.
How did you know you divide by 6? And
It was the smallest side here. It was the smallest number in the root whose square root is not known unless you punch in the calculator. In this exam, do not allow calculator. So it means that you have to, because
I'm done, sir.
okay. You find it hard, you can't easily reduce, you can't increase this 6 to 24 or 24 to 294. You'd have changed the whole question. So you reduce those that are big to the smallest so that you can have like terms and then do the addition. Okay, given this guy as a binary on the set of real numbers, determine whether the binary operation is commutative or not. So you check commutativity. If it's commutative, then we require that A star B be equal to B star A. If this happens, then it is commutative. So now A star B is already given in the question. So we have to talk about B star A. So B star A is equal to, here you change the order now. Instead of saying AB, you say BA. Minus, instead of saying A minus B, you say B minus A squared. But look, we are comparing this thing to A star B, which is the question itself, which is the definition itself. So you come here, and since A and B are real numbers, then BA is the same as AB. Minus, if you go inside the brackets here, you may choose to factor out the negative. Because you factor the negative, it means that now you're dividing B divided by -1. Okay, so you're factoring out -1. So B divided by -1, this becomes negative B. Negative A divided by -1, you get plus A. These are under the square. Fortunately enough, you would have done exponentials as you write this exam. And under exponentials, you know that if I have AB to the power M, I can easily give M to each of these guys. So borrowing from this property, we are going to have AB minus -1, we give it power 2. And negative B plus A still under power 2. But we know that -1 squared is just 1. Multiplied by, we can write this inside like that. So that we have AB minus A minus B squared. And this is the same as what we have, the definition of A star B. Hence, star is commutative. Then they give you a simple one. Use the definition to find 3 star -1 star 2. You just start with this one. What is -1 star 2? Go in the definition. You have -1 multiplied by 2. Hello?
For question A1, is it okay to use numbers like for commutative to check?
No, you don't use the examples to check, to agree. You use examples to disagree.
Okay, so excuse me, sir. For the given question there, can you check for associativity?
You can check. That's not an easy concept in most cases, so it's really examinable. They will only ask it in this part in most cases. I don't want to give you much headache. So if you are given to evaluate this, how do you do the evaluation? You first pick what is in the bracket, star, -1, star 2. So whether it's A, you take -1. Whether it's B, you take -2. Whether it is A, you take -1. Whether it's B, you take +2. So here you get -1 times 2, you get -2, minus -1 minus 2, you get -3. -3 squared is +9. So we get -11. This -11, we take it where there is this brackets now. This guy is equal to -11. So it has now become our new B. So now we go back to the definition and place 3, -11 minus 3 minus 11 squared. This is -33 minus 3 plus 11, that is 14 squared. So this one, you do the calculations here. You must get the value here. What value is it?
The paper was there, huh?
So I get,
Excuse me, sir.
hello?
So which question are we doing?
We are doing this question.
Sorry, I mean which paper?
Oh, 2020.
Okay, sir.
Nachimba. So -196 minus 33. So here it's like you're doing the addition. So what do you get? You get 9 the other side, you get 7, you get 1 negative. So we log out and quickly log back once the system cuts itself.
So, I think you should check the answer for 14 squared. It's supposed to be 196.
I've used 40 years, 96. All right. So check this out.